a bit challenging, a bit of focus from you. In this first session, I will be like throwing you in the water and trying to find your way, because some of you will have a lab today or tomorrow. So I really want you to get only for today.
Emergency case, we only have it left.
Okay, so in all cases, you need to be equipped with the basics. So when you go to the lab, hopefully you can follow a little bit in a little bit better way. So, so let's get started. So first, let me remind you about synchronous and async things. And to give you a concrete example, maybe I'm not sure which example should I give. Let me see. Maybe the example of you have. Sorry. Yes, no, we want to take, email is but it is from real life also. There's another example I can think of. Let's say you want to do some changes, or you want to do some fixing to a dress, or you want to make a new dress. And you go to the tailor. So you have two options. Either you go there, they will take the measurement, and you wait for it to be fixed or to be altered, and you get it back. That's basically synchronous. When you are waiting, you are kind of doing nothing. Maybe you are missing lectures or missing important things. And you are blocking until you get back the result. Another way is what you do, better way. Limits, and how they will let you know. You give them your number, and then when it's done, they will call you back, okay, to come and collect it. So that is basically the idea of asynchronous. Asynchronous programming is all about making a call, don't block, don't wait. Instead, what you do, you give a callback. You give a callback mechanism. Tell them, when you finish, please call me back and come and collect it. Or send it to me at this place. It is still a callback. That is the idea. So let me show you this in concrete way, what it means. Here is an example of synchronous call, and what's the result of using a synchronous call. So let me open this in Chrome. So if what you're doing is super fast, it's not a problem. So if it is very, very fast, it doesn't matter whether you, synchronous or asynchronous. Sometimes it's much better to just do it synchronous. Let's say you want to withdraw some money, you basically very fast, hopefully not long queue, just queue and put your card and get the cash. Much harder to do it. Here's my card, call me back when you get the money. Maybe it's much harder. So if it is super fast, this is not part of it's not a concern. I click this button and I get the results. Very, very fast. The problem is when I have a long-running operation. This is where the problem comes. Have a look at this. I click this one, khalas, whole thing is blocked. I'm not being able to do anything until this. Of course, when the results come back, these were queued. These requests were queued, and they were executed after. So, but the idea here, to have a good user experience, I don't want to have this scenario where the user is blocked. User blocked means the user is not happy. That's it. That's the idea. So I want to do it in a way that I don't block the user. So that's why anything long running, I don't do it synchronously. I don't call and wait. I call and give a call back for the function I call to call me back when the results are ready. Okay, so you get the idea. So here is the browser. So the browsers of the world, one of their components is a JavaScript runtime. This is the one responsible of getting the JavaScript that is included in the file and executed. This, by design, this JavaScript runtime is single thread. Single thread, which means it can only do one thing at a time. One thing at a time. So that's why, if there is anything long running, especially here when we talk about long running, for example, you want to get some data from the server side. So between the client and the server, there is a network. So that network could be congested. Many people are trying to do the same thing. Maybe the server is busy. Or maybe the operation takes a long time, even if the server is not busy. So you don't want to make that call to the server side and wait for it. Instead, what you do, the browser has some built-in API. For example, one of them is a function called fetch. I said to the browser, please go ahead and fetch for me, get for me this data in this URL, and when you are done, call me back. This is a callback. So a callback is a function that I give to when I call a function, I give it another function as a parameter. That's what a callback is. Now, when this function is finished, the browser also has a queue, a little queue here. Let's call it the callback queue. Okay? So when I say, okay, fetch google.com/ let's say weather/Doha. Give me the weather in Doha, for example. So I keep going here, the browser is still responsive. If the user clicks something, I can still do some other things. So when the browser finishes getting the information from this URL, it will queue a call to this callback function. It will queue it in this queue. And here, whenever, there is also a loop here called, sorry? What do we call it? Sorry? Callback loop. Or I can't even remember the name of it. Anyway, there is a loop. What this loop does, basically whenever this thread is not busy, it will pick up these queued calls and executes them. Okay? So this is in a simple way. If you really want to understand it a little bit better with visualization, have a look at this video. But with this discussion, maybe now it will make a little bit more sense. So to summarize, any long-running operations, you don't execute them here synchronously. You give them to the browser to do on your behalf. And when you call a function for the browser to do it for you, don't forget to give a callback function. And when the browser is done, the call will be queued. And whenever the JavaScript runtime thread is not busy, it will execute those queued calls. So it makes a little bit more sense if I give you an example. Here is an example. So let me show it to you. So what I have here, browsers can know your location if you allow them to do so. So in the browser there is this built-in object called navigator, and this built-in object has a function called geolocation, and this object has a function called getCurrentPosition. Okay. Now, when I call this function, I don't call it and wait for the results. I call it and then give it a callback function. So when this, who will execute this method? GetCurrentPosition. Is it the JavaScript runtime or the web API? The web API.
Yes.
The browser web API. The browser web API will execute this, and the browser runtime, the JavaScript runtime, will not wait. Instead, when I call this function, I give it a callback. Same way, when you left your dress to be fixed, you didn't wait for it to be fixed. You basically gave your phone number or address and asked the people there, when they finish, what they will do? They will call you back. Same thing here. I call this function and I'm not waiting for it. If I was waiting for it, I would have said here, let's say let x equal. This is waiting. Instead, I didn't do this. This is synchronous. I said, okay, when you finish, please call me back. And this is the number I want you to call me back on. Or this is the function I want to call me back on. This is called, what do we call this function? A callback function. It's basically a function. And when this function will call this show position, it will give it the result. Okay. So, for example, when this delivery, let's say you go to this tailor and say to them, when you finish, please deliver the item to this address. So when they will deliver it to you, or when they call you back and knock your door, hopefully they are not coming empty-handed. They are coming with the results. So same thing here. When this one is called, this get position will give you back the results you are waiting for. And then you do whatever with them. In this case, I am going to this demo paragraph and I'm sticking the result in there. There's a demo paragraph here. I get a reference to it and set the inner HTML to latitude or longitude that I have received. So let me show you this running.
So the third we called that, the method that we send it to be called back is part again of the web API or the Java?
Very good question. We define it and it will run here in JavaScript runtime. Yes. As you can see here, have a look. This one is part of the web API. Get current position is part of the web API. This show position, my callback, is part of my application. And here is the definition of it. Now, this is not to scare you, but JavaScript people don't do this. They just put it like this.
Yes.
That's it. This is how they do it. This will not scare you because you have seen it already.
Yes.
But just, anyway, I will put it back here. So same thing. Basically, I am passing a function to this call.
Here the callback is a parameter, but we didn't pass any parameter. It does know.
No, basically, look.
Yes.
This one will be called,
Yes.
and any parameters that is passed will be assigned to this position. Okay. So when I give you the callback, I don't tell you this is the parameter I'm expecting from you. Okay. So there is no need. You just specify the function name that you want, that you want the function to call when it's done. Okay. This is the power of JavaScript. It's very dynamic. So whatever the function will be passed into this callback we will receive it in this parameter. And this parameter you can call it whatever you want. Data, results, whatever. In here I call this position. This is because I'm expecting a position coordinates to come back.
Yeah, it's like the intent of the get current position, but here value will be passed to the callback.
Yes, yes. Basically, in here when I put the callback, I don't specify the I'm just giving the function name.
Yes. Without the structure.
Yes, please. Sorry.
Without, the signature.
Without the signature. Or if you wish, if this does not really scare you, you can always take this and put the whole thing here, no problem. In fact, you can even remove this. In here you are giving the whole function definition. Or you define it and then pass the name. This is much lighter weight for you to do now. And it's a good thing to do. So let's keep it this way. So let me show you here. So when I run it, I basically, here the browser is asking me for authorization. So I'm authorizing it. It will take some time, but I didn't put here a button. I should have put a button. So it took some time for this to come back. But during that time, the browser is still responsive. Let me prove it to you. I think I will just take... No, if we click it, will do another call. No, but I will show you another way. So very quickly, here is my greet. I'll copy this from the other example, okay? Here is my greet, and let me put it in here. I will just call this one get location. And let me take some of the code that's coming here. Here is the code, okay? Copy this, and I'll go to the callback. All right, and I'll put the code in here. Ah, yes, thank you. All right, so in here, instead of result, I will call it demo. All right, and in here, I will add whatever was there, I'll add to it instead of overriding. And I will just put here a new line, so everything will be in its own line. New line is basically, in HTML, new line is BR. All right, so let us try. So here is the call. All right, so I make a call, get location, I authorize it, but this one is still responsive. Okay, and when the call came, no problem. If it was synchronous, this will not be responsive. You see the power of asynchronous? Of course, this one is funny because it's not. Yeah, I have to put this. Okay. No, I just put this metadata here, meta tab in the header to tell the browser, be aware some non-English text will be coming towards you. Be prepared. This is what this will do. So let me just refresh. This is the location, no problem. While it's very fast this time. Okay. You see, while it's doing its work, the browser is still responsive. And this is why callbacks are very critical. That's why we are covering it. It's part of the 20%. It's not something advanced. It's something that everyday JavaScript developer use. Because of the nature of JavaScript being a single-threaded, you have to delegate the work to the browser to do on your behalf, and then you give it a callback. And for example, for fetch or for get geolocation or other functions, you have to call it and give it. It is clear?
Yes.
Okay. So now, yes, please.
Synchronous, it's not going to use the web API.
Yes, if you use Synchronous, like for example, this is a good question. Let me. Yes, of course. Okay, so let me open this again. All right. So this one, you see, very fast. This one is synchronous, but unfortunately, the work done in this function is very, very heavy. There's a big loop, 1 to 1 million, and try to sum those values and do the average. In here, there is no. The web API will not help you. Web API is usually you use it if you want to get some information from the server. It will take some time to get it, so you do this callback things. Now, if you have a long-running script that you want to have in your browser, you have to run it in a separate thread. So you have already seen this in operating system. So in JavaScript, and by the way, this is quite new in the new browsers. If you use some old browsers like IE, it doesn't have this feature. So in this is just to let you know, but this is different than asynchronous. This is threading, basically. Asynchronous is another mechanism to allow this non-blocking. Okay. So in the web browser, we don't call it a thread. We call it a web worker. So let me just show you very quickly. So the browser has an object called worker. Okay. What you give it, it creates an object out of that work, and you give it a script. And you say, please run this script in another thread. Okay? And then I listen to this thread. This thread, unfortunately, does not have access to the DOM. Remember the DOM?
Yeah.
This thread is, only this main thread has access to the DOM. So what will happen is the worker will do its work, and I have to listen to the worker in case they have something to tell me. How do I listen to the worker? By listening on this on message. When a message comes, this function will be executed, and I'll get the data that the worker is passing to me. So that's another way. So if you have some heavy, long-running script that will take a long time and block your UI, what is your solution? Give it a web worker to do. Now here is the web worker. It's just a file that has some bunch of JavaScript, except instead of using return, it uses post message. Post message means the worker will be communicating with the main thread saying, here is the result. Of course, the main thread can also post messages to the worker. So there is a bidirectional communication, exchange of messages between the two. This is another way of doing a non-blocking UI. So if you are dealing with the server, just use the web API and pass callbacks. If you have a long-running script that the browser does not know how to do for you, you have to use a script and give it to a worker to do on your behalf. To leave the main thread always ready for corresponding to the user actions. Never run something heavy or longer than the main thread. Is this clear? Okay, so now let's switch now to the server side. Node.js. Remember Node.js?
Yes.
So same thing. It's a JavaScript runtime. Same concept. Is still a single threaded. Okay, and then whenever you need to read and write from a file, here is Node.js. Remember, here is Node.js, not the browser. So this, on the server side, there is no such thing as web API, browser web API, because there is no browser on the server side. Instead, there is I/O API. I/O, which stands for input-output. You know that reading and writing to disk is the most expensive operation in a program. Okay? So in Node.js, you should never do a reading and a writing in the main thread. You should delegate it to the I/O API, and when you call a function to read or write to a file, you give it a callback. When the data is ready, the API will call back the main thread. And it is the same idea. There is a queue where the callbacks will be queued, and there is a loop that watches this thread. Whenever it's not doing anything, it will pick up some work from the queue and execute it in the main thread. And this happens to be very, very powerful idea. And that's why Node.js is very, very popular. And it's more, in terms of performance, it's much better than Apache or some other web servers. Traditionally, in the past, or even now, most of the servers, what they do, for every new request, they create a new thread to handle it. Okay? This one is okay, but at a certain stage, you will hit the limit. Because every thread needs resources, memory resources, CPU resources. Yes. Instead, Node.js's promises, and it has been experimentally tested, is much, much more powerful and more scalable. Let me make it more clear, more scalable. The reason why, you have only one thread that handles all the requests, and heavy ones are delegated to this input-output API, and this input-output API, it manages a pool of threads. So instead of one request, one thread, you have just one thread for all the requests. And any heavy work is delegated to a thread pool.
The thread pool, for example, has a limited number of threads.
Yes.
And it manages them.
It manages them. Whenever somebody needs them, they use the thread and come back to the pool.
One thread at a time.
No, basically, thread pool is basically a set of threads ready to serve any request.
So
it's not.
They all work at the same time?
Yes, they all work at the same time. No, it's basically multi-threaded. Basically, if I have multiple users asking for file 1, 2, 3, let's say we have 10 users asking for different files. File 1, 2, 3, 4. So we have thread 1 will read file 1, thread 2 will read file 2 at the same time. Okay? But the only difference is I don't have one request, one thread.
Yeah.
Because some requests might not need an input-output.
Yeah.
Okay. Anyway, we will go through this in more details. I don't want this to drag us. So the main thing first of all, for now, is the idea clear of asynchronous call?
Yes.
Just to summarize it, asynchronous means you call a function, you don't wait for the result. Instead, you give it a callback function.
When it's ready.
Yeah, when the function is done, it will call the callback. That's the idea. Now, let me now show you this idea in the context of Node.js and in the context of reading files. You know, in the browser you cannot read files, as I explained before, for security reasons. But in Node.js you can read files. Now let me quickly show you, here's the file we want to read. It's just an array of students. And we have student details with the courses that they are taking. So I will just create a new file very quickly, a new JavaScript file. Here is the new. Okay. Sorry, that's not what I intended to say. Right, new. JavaScript file, and I will call it just, so hopefully it will be on top. Oh, still in the last. All right, no problem. So let me just take this one. All right, no problem. I will, just to save time, we'll just take this quickly. Here it is. So I will, okay, that's it. Here it is. Here it is, console.log. Data. Oh yes, thank you. That's it. So if I want to read from files, there is a built-in library called FS, which stands for file system. I already explained this required last time, if you remember. If I want to use some existing library, because this one is literally used, is already part of Node.js. I just say, please bring along the file system library and go ahead and read this file. In here, the path is, here is the path. That's it, here is the path. So I'll go here. Let me just put it here, let file path. So it will go to the folder data. Dot stands for the local folder, the current folder, slash data slash students. Okay? So let me just run this.
Local folder, you mean the local disk?
No, dot is the current where you are standing. Okay. All right. So did it do anything? Yes. All right. So let me see. Maybe let me put this one. JSON dot parse. Sync. All right. So let me try it.
So this will be in string?
Yes, here it is. So what I wanted to show you here is I have a files path, and I'm using this file system library, and I am calling this function called the read file sync. Read file sync means read it synchronously. Like read it, I'm waiting for you. I'm not going anywhere, read it and give me back the result. This is a synchronous call. When I finish, I get at my hand the actual data coming from the file. Good news, you have the data, but you have blocked everyone else. Because while you are doing this, I suppose, usually this is a longer audience, because disk is something shared, and many users will try to read from it at the same time. And it's mechanical, typically, especially the old disks. They are mechanicals that they take a longer time compared to accessing memory. So you don't want to do this. This is not very good programming practice at all, because you are blocking everyone else, and they have to wait for this to finish. So instead, you should never use this read file sync. Instead, what you should do, don't expect the result to come back immediately. Do read file, give it the path, and then give it a callback. So here is, let's say, done, okay, which is a function. And basically, I create here a function called done. And basically, there are two possible things that can happen. Either there will be an error, or I'll get back the data that I asked for. So that's why two things can come in, either an error or data. Now, you might think that these Node.js people are pessimistic and they always think about the bad things first. That's not the idea. The idea of putting the error first is...
Don't tell us, don't do it.
No, not really. Like it is a little bit counterintuitive, because you might have thought, I'll get the data, who cares about the error? But they want you to really think about the error. That's why this read file will give you back either an error or a data. So the callback function has to have two parameters, error and data. Okay, and inside here, have a look. Inside here, what you do is...
Only when dealing with files, Doctor?
Sorry? In general, we will see this pattern very much repeated all over. Always, so Because programmers, they tend to take the shortcut and forget about errors. But in here, this pattern kind of forces you to think about errors. So when you do callback, you provide two parameters, error and data. Okay. Yes. So if there is an error, all I will do console dot log and basically put the error there. This is if there is an error. Yep. All right. Okay, that's it. Else, I will basically post. I will basically display the results. Okay, it's clear? So that's it. In here, it is now asynchronous. When I make this call, it will be delegated to the input-output API. It will run on a separate thread. When the results come back, my done function will be called. If there is an error, I'll find this in the error parameter. If the data is read successfully, I'll find this in the data parameter. Okay? So let me run this. Exactly the same result, but this program is scalable. The other one is not. Here it can handle multiple concurrent users. The other one is single user at a time. Big difference, huge difference. It is clear, the idea? Now let me try to do something like a file that does not exist and see what will happen. Run, and I will get an error with all the details of it. Okay? And you can see either an error or done. Now, of course, this is fine, especially as beginner, it's recommended to do it this way, but as you move up, you will just cut this and just stick it in here directly, no problem, and even make it a little bit scarier with this. That's it. This is how it is done, run. Okay, let me fix it. And run this. That's it, it gets the information. Same exact, this is the idea of asynchronous calls. Now, of course, let's say, you see here, have a look at this, courses IDs. Let's say these courses IDs are not very meaningful. I want to know what are the courses, what do we mean by 107? What is the course details? So what do I need to do if I want to get this information? What are the course details? I need to read it from another file called course. Have a look, sorry. There's another file here called course, and it has the details. Okay, so let me just go back there. Now, if I want to do this, I'll have to kind of repeat this. This is where it becomes a little bit complex. When you have multiple actions that are interdependent. You have to do the first one, and based on the result of the first one, you go and do the second. Okay? So in the synchronous world, it's super easy. That's why it is easy for you to understand it. In the synchronous world, you fetch the students, then you get the courses for each of the for the students, and then, of course, the course also has the instructor ID, which we will go and read from a staff file. So in synchronous, we are very used to this. This will not scare us. But in asynchronous, it looks different. And that's where the challenge is, when you have multiple tasks that are dependent of each other. Okay, so let me show you in here. So let's say we are in the happy scenario, and we got the data. Then we want to get the courses. Then we have to put that call within this success path. So I paste it here. Not only this, sorry, I'll have to copy almost the whole thing. Of course, I can make these functions and make it more interesting, but for now, let me just put it this way. So in here, I will go and make this one, let's say, here it is, course. All right, and of course I will do some more processing here to only get the courses that are for this particular student. But let's not do that. I just want to show you that for not nested, like multiple calls that depend on each other, like your code will grow like a pyramid. Okay? So your code will, typically in synchronous programming, the code grows only vertically. So your code will become longer. But in here, not only your code becomes longer, it becomes longer and wider. Okay? And this is called the pyramid of doom, or the callback hell. This is what the JavaScript program is called. The more you have interconnected calls, the more it becomes complex and not easy to understand. So let me just run it very quickly. Of course, in this one, let me just show you only one. Basically, it reads all the courses. But it doesn't do the whole thing that we want to do. The whole thing that we want to do is nicely done here. All right, here it is. A second. Here it is. Here it is. That's it. Here it is. Okay. This is how to do it properly. So in here, let me just show you. I have a function called a read JSON file. It takes the path that I want to read from, and it takes a callback. Then it goes ahead and reads the file, and then it says, okay, if there is an error, I pass it back to the callback. If everything goes okay, I will pass null for the error and pass the data, convert the data to JSON and pass it to the callback. Okay. This is a very generic asynchronous code to read from the file.
So there is like overridden callback function, like has two signatures in this case. Like one only takes.
No, there is only one. Very good question. There is only one. Remember that I have here. If there is an error, so basically the way it works, remember JavaScript is dynamic. Even if you have multiple parameters, you can only pass one and ignore the rest. Okay? Yeah, this is you don't need to pass all the parameters. In fact, if you look here carefully, the way I do it, if there is an error, I don't even look at the data.
Yes. Okay.
You see here? If there is an error, I just handle the error and forget about the data. So that's why I can call this callback with one parameter. So one function can, although it expects two parameters, I can call it with one and ignore the other one. Okay, so it becomes a little bit complex. So let me show you. Where it is, asynchronous. Yes, here it is. Okay, so here is how I read the student. So I do read JSON file, and I give it a path, and I give it a function as a callback. Okay, and I say here if there is an error, because remember this fetch student will also be called by another function. Okay. So I say here if there is an error, I want you to just tell the caller that there is an error. Otherwise, I want you to only get the student that the caller has requested. Not all the students, just one of them. All right. If the student that we're looking for exists, then return it. But please remove the password. We don't want people to see our passwords. Otherwise, I want you to return an error to the caller, saying there's no record. Okay. So basically, this is how you really program an asynchronous function. It's a bit hard. You need to get used to it. Through a little bit of practice, it becomes a little bit easier. Okay. Here is the same thing. Get courses, exactly the same concept. Here is get instructor, exactly the same concept. And here is the get student. If you remember, if I want to get a student, I first get the student details. Then for the courses they take, I get the details of those courses. And for each of those courses, what do I get? The instructor of that course. So it's the three calls inside one another. Have a look how we do it. So first I fetch the student. and I get back the student. I save it in this variable. Then I go ahead and get the I get the courses for the courses of the student, and I get them back hopefully and store them in the student. And then for each course, I go and get the instructor. So this is how I do it. It's a bit more complex than the synchronous course. And you can see here, although I'm using functions and making it a little bit lighter, my code is still growing this way. If I don't use these named functions, my code will even be worse. Now, to solve this, just give me 5 minutes. I want to show you another better way. So people have been doing this from the 19s up to now, since JavaScript came up to now, until 2015. You're lucky to take this course after this year. So 2015, people said, okay, let us do something about this pyramid of doom where my code keeps growing this way and becomes complex. So they introduced a concept of promise. So what is a promise? In general, in real life? Yes. It's something that I promise to fulfill in the future. Usually it's related to the future. And hopefully either I will deliver what I promise or I will give you an error. Okay? So a promise is something, it's a future value. It's a future value that I promise you to provide. So it's an abstraction. Instead of thinking about callbacks, you start writing your code or thinking about it as a set of promises. But the good thing about promises, you can connect them in a better way than this way, as I will show you shortly. So let me show you a small example of what a promise means. I know there is a lot here to take, but the idea here is just to introduce it, although it's not in a very clear way, and hopefully in the lab you practice a little bit, and then we come back next class and make it clearer. So let's take an example of a promise. Here is the simplest example. Let's see. Here is how a promise looks. Maybe this is not the best. Sorry, this is not the best example. Let me show you. Maybe this one. I think you can handle it, although it's a bit scary.
It's available in both browser and the Node.js.
Yes, it's available in both. So a promise is nothing but an object that takes two functions. Resolve. This function will be called if everything is successful. Or reject if I'm not able to fulfill the promise. So basically a function returns your promise. A promise is an object. You can see here I'm creating an instance of object called promise. And this object, when you instantiate it, it receives two functions. One is called resolve. You can call it whatever, but this is the pattern you people use. One is called resolve. It will be called if everything is successful. One is called reject. It will be called if there is an error. Here, this one should be familiar to you. I'm reading from the file asynchronously. Two things might happen. Either an error or a data will come back. If there is an error, I will call the reject function. If it is not an error, I will call the resolve function. That's it. This is how I do it. Exactly the same. Have a look at student. The get student, because I cannot give it to you now. In Synchronous, you wait and you get what you asked for right now. In asynchronous, really when you call it, what do you get? You get a promise. Either it will be fulfilled or it will be rejected.
But you resolve before reject.
Yes, in here we are optimistic that 99% of people will try their best to fulfill their promise. Otherwise, we will be in a bad shape society. So, here it is. So, exactly the same, I'm reading. Here, sorry. Let me show you. Let me show you how do I link. When I call, this is a promise. This read JSON file is a promise. Okay, when I call it, have a look. I'm calling this function. This function returns me a promise. So the way I do it, I'll say, when I call it, I follow it with this then. Says, I'm calling this function, then in the future when the results come back, I want you to do this. Okay? Now, maybe it will become clearer if I go to the last one. The last one, instead of having my code grow horizontally and create this pyramid of doom, it's back growing vertically. So the way I do it, look at this. I say, please go ahead and get me the student details for student ID, whatever. Then, when you get it, please go ahead and get the courses. Then, when you get the courses, please go ahead and get promise all here. This is another very powerful feature. I can do multiple promises at the same time.
Yeah.
When they all come back, I do the next step.
Yes. The error will be the last one.
Here, one error handler will handle any error that happens in it. Very powerful mechanism. So just to summarize, you need to practice this to appreciate it. But just to summarize it very, very quickly. We have functions. The function can either be synchronous or asynchronous. Synchronous, you know it, you have been doing it all this time, all these years. Now asynchronous is a bit hard, a bit different mindset. So asynchronous function does not return you a value immediately. What does it return you?
Callback.
A promise. Two ways. Either you give it a callback and it will call you back, that's one mechanism. But since 2015, a better mechanism, a better way of thinking about it, is to say a function does not return a value. What does it return? A promise. And then, you see here, when the promise is fulfilled, I can do some other things. So composing promises becomes much, much easier. So here is a promise, here is another promise. What is it? Here's another promise, here is another, what is it? Here it is. Here's another promise. So the way I compose them is through this then. Then function. And there's a catch to catch any error that will happen here. So this then is the function that will be passed to resolve. This will represent the result, and this one will represent the result. So if any of these promises is rejected, the execution will jump to the catch. Okay? And also, if you have multiple promises you want to run concurrently, and you want to wait for all of them, in the callbacks, much, much harder to do it. In here, the promise class has a static method called all, and here I am called for each course. I am calling this get instructor. Okay. And then when it all finishes, I will get the student and display it to the screen. When I display it, have a look at this very quickly. When I display it, I get, here it is, I get the student, and I get the details of their courses, and for each course I get the instructor. Okay. So the last thing, sorry, just give me 1 minute. I know I'm taking overboard. Here it is. The last thing I want to show you, which we will discuss next time, in 2016, this year, a new and better way, a little bit better way. Here it is. This one. That's it. Sorry, here it is. Yes. Yep. Here it is. Instead of those then, we are back to almost synchronous. We say, this one looks like I am doing synchronous code. But to make it asynchronous, I just add this keyword wait. Which means I want you to call this, don't block the other users, but use a queue to wait for the results to come back. So it's exactly the same. We are waiting for the results. It is a much nicer way for us. All right? This is fresh and brand new technique that is in JavaScript 2016. Because this one is still not supported in all the browsers, you have to compile it to a previous version. This is called transpile. So before you run it, next time I will show you, you have to compile it to the previous version. And of course, the previous version is a little bit more scary. Okay. So I know it's a lot of things to get in, but I am aware of that. This session, I just want to introduce the idea in overall. So you have it kind of enough, a little bit enough. You still have a little bit of effort to communicate more details to you. And then you practice as much as you can, you try to understand it as much as you can. And next time, inshallah, we'll discuss it further and clarify further. Method next week. Is next week the last week before the break?
No, there is a next week.
For me, it's fine. I'm just worried about some of you might want to escape, that's why.
No, we can start
So that's fine, because just the university encourages us before the ability to drop without penalty. You know what I mean? So,
No, there is a penalty, but
no, what I mean without showing. It doesn't show as. Yeah, but
the penalty will be the whole price of the course.
yeah, but it doesn't show in your transcript, is it?
It does show.
It does show as with the drop.
Yes, even
So what is the difference?
I don't know what it is.
Oh, if you drop before, after it will be F?
No.
But there is a deadline before you cannot drop after it.
No,
you're stuck in the course.
Yes, you will be more. It will.
Yes. We can make it the week just with the week before. I will send the actual things. So the practical will be in class. And the theory
But the practical will be.
Sorry, the theory will be the lab and practical in class. And the practical will be in one lab, similar to what you would do one month, this Monday.
دكتور زياد حكى لنا نحن في نفس الوقت.
Yes.
الليكتشر. أنا نعمل اللاب والهدف كله نفس الوقت.
But then
We should know the 3 weeks for the latest. For those the 3 weeks. We have them.
you have to know the 3 weeks.
And those.
Because in practice, they build on each other.
Yes.
For example, to use this way, a simple way to see it to response.
No, the promises and the weight are okay. I mean the pyramid one.
Yeah, you don't need to.
Okay.
See what So you need to be familiar with it.
Yes.
Thank you.
So we need the 3